You have been drinking coffee wrong your entire life. Not the temperature, not the brewing method, not the roast. The problem is what is missing from it. There's a compound that has been sitting in your kitchen the entire time. It costs less than $2. It takes 3 seconds to add, and it intercepts the single most damaging thing your morning coffee does to your body before you even notice the damage is happening. It has been studied in peer-reviewed journals for over 30 years. And the industry that profits from your morning routine has exactly zero financial incentive to tell you it exists. This is brain glitch, the science behind why your life is weird. Here's what your coffee is actually doing to your blood sugar every single morning, and why the fix has been in your kitchen the entire time. Most people think of coffee as a neutral drink, water, caffeine, antioxidants, mostly harmless. That is not the complete picture. When your alarm goes off, your body is already running an emergency hormonal sequence before you pour anything. Your adrenal glands release a large spike of cortisol within the first 30 minutes of waking every single morning. This is not stress. This is your body's biological ignition, the signal that tells every organ the day has started. A 2004 review in Psychoneuroendocrinology confirmed this cortisol awakening response produces a 30 to 45% increase above baseline in healthy adults every morning, regardless of sleep quality. Your blood sugar is already climbing before you touch the coffee maker. Then you add caffeine. Caffeine triggers a secondary cortisol release through the adrenal axis, a separate wave of the same hormone on top of the one already running. At the same time, caffeine signals your liver directly to convert stored glycogen into glucose and release it into your bloodstream, a process called glycogenolysis. Your liver is dumping fuel into your blood because caffeine sent a message that a threat was present. A 2008 study in diabetes care found caffeine increased post-meal blood glucose by an average of 21%. Later research confirmed the same glucose-raising mechanism is present in healthy adults too, smaller in magnitude, but identical in process. Every morning, before you eat anything, your blood sugar spikes from cortisol, then spikes again from caffeine. Then your pancreas releases insulin to bring it back down. And insulin, in the presence of a large spike, frequently overshoots, driving blood sugar below baseline before stabilizing. That sub-baseline dip is what neurologists call reactive hypoglycemia. What everyone else calls brain fog, inability to concentrate, irritability before 10 a.m., and the specific experience of sitting in a meeting and understanding approximately nothing. This is not a personality flaw. This is glucose falling below the threshold. Your prefrontal cortex needs to run executive function. Your brain is 2% of your body weight and uses 20% of your total caloric energy. It runs almost entirely on glucose. When blood sugar crashes after the morning spike, your brain is the first organ to report the shortage, and it reports it as exhaustion, fog, and the need for another coffee, which restarts the exact same cycle. This is the loop. Cortisol spikes blood sugar, caffeine spikes it again, insulin overshoots on the way down, brain performance drops, another coffee, more cortisol, repeat. Most people interpret this as a caffeine dependency or a bad night's sleep. It is neither. It is a blood sugar management problem that your morning routine is producing and then hiding from you at the same time. If you have made it this far, you already understand something about your morning biology that most people never learn. Leave the word glitch in the comments so we know you are here. The supplement industry built an entire product category around this exact problem. Products with words like glucose support, metabolic balance, and insulin sensitivity complex on the label, costing $30 to $60 per bottle. Most of them share the same primary active compound. That compound is not a pharmaceutical invention. It is not a patented molecule. It was documented in scientific literature before most of those supplement companies existed. And with near certainty, it is already in your kitchen right now. Here is what is actually happening at the cellular level when your blood sugar spikes, and why this specific compound intercepts it at the exact moment it matters most. Your prefrontal cortex, the part of your brain responsible for reasoning, planning, impulse control, and the ability to function in the first 2 hours of the day, runs on glucose more than any other brain region. When blood sugar drops below approximately 70 milligrams per deciliter, measurable impairment in prefrontal function begins. Researchers at the University of Southern California found that subjects in a mild hypoglycemic state scored significantly lower on tests of working memory and cognitive flexibility than subjects with stable glucose. Not high glucose, just stable. The morning loop is not making you tired. It is making you temporarily less intelligent, less patient, and less capable of focused work before 10 a.m. And the $2 fix for this has been in your spice cabinet the entire time. There are 2 confirmed cellular pathways through which this compound acts on your blood glucose, both identified in independent laboratories, both replicated across multiple studies, and both targeting the morning spike at the exact moment it does the most damage. The first pathway involves a protein called GLUT4. A glucose transporter embedded in your cell membranes, a channel whose job is to open and pull glucose from your bloodstream into your cells. Insulin is normally the key that opens this channel. But when insulin resistance develops, the channel stays closed, glucose accumulates in the blood, and the spike lasts longer and goes higher than it should. This compound activates GLUT4 through a pathway that runs alongside the insulin signal. It does not replace insulin. It increases the number of active channels available, so glucose clears faster and more completely. The second pathway is alpha-glucosidase inhibition. Alpha-glucosidase is a digestive enzyme that breaks complex carbohydrates into simple glucose for absorption, and when it works quickly, you get a sharp, concentrated spike. This compound slows that enzyme down, producing a flatter glucose curve with a lower peak and a smaller trough. And some of the most widely prescribed pharmaceutical glucose management drugs in the world work through this exact same pathway. A 2012 meta-analysis in the Journal of Medicinal Food reviewed 10 independent randomized controlled trials on this compound and glucose metabolism. The conclusion was a significant reduction in fasting blood glucose, triglycerides, LDL cholesterol, and total cholesterol. The cholesterol and triglyceride findings were not the primary hypothesis of any of the studies. Researchers found them anyway across 10 separate trials. Those are the 3 biomarkers most primary care physicians test to assess cardiovascular risk. And the compound producing those results costs less than $2 per jar. Now here is the name, and the one detail about it that changes everything about how you use it. Here is why the morning window specifically is the highest leverage moment in the entire day to address this. Your cortisol awakening response peaks within the first 60 minutes of waking, not in the afternoon, not after lunch, not before bed. In the first 60 minutes, before most people have eaten a single thing. During that window, blood sugar is rising from cortisol alone, with no food in the system to slow the absorption curve. Then caffeine adds a second stimulus to a liver that is already responding to the cortisol signal, and the compounded result is a blood sugar event that happens faster and steeper than either trigger would produce alone. By the time most people notice they need a second coffee, both spikes have already peaked and the insulin overshoot has already happened. The intervention window is closed. Adding cinnamaldehyde to the first cup places the compound in your digestive system before the alpha-glucosidase enzyme is at its most active, before the glucose curve has started its climb, at the exact point where slowing the enzyme makes the largest difference to the shape of the curve. That timing specificity is what separates this from taking a cinnamon capsule at noon. The mechanism is the same, the window is not. The morning window matters because blood sugar events earlier in the day have a cascading effect on glucose regulation for the rest of the day. A large spike before breakfast primes your insulin response to overreact to the next glucose input, meaning lunch produces a larger crash than it otherwise would, meaning the afternoon cognitive dip hits harder, meaning the cycle of cortisol, caffeine, and glucose instability compounds through every meal until you sleep. Intercepting the first spike does not just improve your 9 a.m., it changes the baseline your glucose regulation system is operating from for the next 16 hours. This is why the research consistently shows the largest effects in fasting states. The intervention is acting on a system that has not yet been disrupted, rather than trying to correct a disruption already in progress. Here is something else that almost no article about this topic explains. Why the supplement industry's version of this compound became a category, and why the $2 jar version was never marketed alongside it. The answer is not that the capsule form is more effective. The bioavailability research does not support that claim for this specific compound. The answer is that a spice cannot be patented, a product can, and the economics of supplement marketing require a proprietary claim to justify the price differential. Cinnamaldehyde is cinnamaldehyde, whether it arrives in a $40 bottle or a $2 jar. The molecule does not change based on the packaging decision. What does change is the coumarin content, which the capsule form frequently obscures behind the generic label of cinnamon extract, without specifying the source plant. A supplement labeled cinnamon extract, standardized to 10% cinnaminoids with no source plant declaration, is almost certainly cassia-derived, because cassia is cheaper to source and standardize at scale. The label tells you the cinnamaldehyde content. It does not tell you the coumarin content, and those are 2 completely different numbers with completely different implications for daily use. The $2 jar of labeled Ceylon's cinnamon at your grocery store is the only form where you know both numbers before you open it.